Hey folks, for those that are absent, we're going to take, some notes right now in the video. For people that were in class, we're going to do the notes together and try some problems on the whiteboard. So let's get going. There are two situations that we're going to try to factor, two special situations. And when you're in a math class and you recognize these situations, it saves you time, it saves you effort, it reduces the chance of making a mistake. You feel good about yourself. I mean, there are no downsides to learning about these two special situations. The trick is trying to remember them down the road. A year from now, when you see it again, you'll be like, I don't remember that. Hopefully it'll come back to you though when the teacher shows you that special situation. Okay, so we're going to practice it, try to stick it in our memory bank. We'll use it on the test. We'll try to practice it before the end of the year. And then next year, hopefully you'll remember how it works when you see it. Okay. So anyways, I hope you're getting these notes down right now. And the first special situation that we're going to look at is when you have the difference of two perfect squares. Like they've got to be squares for the in the first term and the second term. And there's got to be a subtraction going on between them. So let's look at these two numbers right here. So we got like the square root of 1. Yep, that's equal to 1. And the square root of 144 q squared. Yes, that's just a simple 12q, because the square root of 144 is 12. The square root of q squared is just q. Remember how the square root sign is the same thing as a half power? Let me zoom in on this. Hold on one second here. Let's say we're looking at q, the square root of q squared. Sorry, that's the same thing as q squared to the 1/2 power, right? The square root means 1/2 power. So we get q to the first power. So that's what makes that a perfect square. And all those other, situations like the square root of 1, square root of 144 is the same thing as 12 squared. That's what I'm saying. So they simplify down, nice and neat. So what's the next step in this problem? Well, the next step is just to say, okay, I'm going to take the 1, that's the square root of the first term, and I'm going to subtract the square root of the second term, 12q, and then I'm going to multiply that by 1 plus 12q. And why does this work? Well, when you have a perfect square, let's see here, let's move this back over. When you have, I should say, the difference of two squares, okay, that came from two factors that look like this, a plus b times a minus b. Why does that work? Because when you do the first, you get a squared. When you do the outsides, you get minus a times b. When you do the insides, you get plus a times b. I'm putting that in alphabetical order. You might say, wait a minute, Nelson, it's b times a. But b times a is the same thing as a times b. And then b times b over here, that gives us a negative b squared, because there's a minus sign here, plus sign over there, right? So do you see the middle terms go to 0, and we have a squared minus b squared, right? Well, there's a plus here, I guess, and then a minus over there, but it all simplifies down to a squared minus b squared. All right, so we're trying to kind of go backward. We're trying to go, hey, I see that I've got this square here and this square here, and we're subtracting them. So that's how the difference of two squares works. Now, let's look at another example. This is the way I'm going to do it in class. We're going to look at this one. This one looks a little bit more complicated, right? And then people in class are going to try B and D, and then we're going to come back. We're going to try letter E. So I take the square root of 25x squared. Can I do that? Yes, I can. I get 5x. I'm going to take the square root of 64y squared. Don't take the square root of negative 64. Okay, the negative is just, it's between the two terms. It's important. We're subtracting two squares from each other. So let's see here. What do I get? I get 8y. Okay, so what do I do next? I go 5x. It doesn't matter if you go the plus 1 first or the minus 1 first, but you need 5x plus y and a 5x minus, 8y. You need a plus and a minus, because that's how you're going to get the middle term to cancel out, as I showed you right over here in our notes. So in class, we're going to go to the board, try these two. These two just work exactly like A and B, so I'm going to skip that for now. I want to show you E here. This one is a little trickier because when you take the square root of x to the fourth, it becomes x squared. When you take the square root of 256, you get 16. Okay, perfect. These are perfect squares. You know, that's what we wanted. So let's see here. I go x squared plus 16 times x squared minus 16. But here's the trick. Like if you put this into McGraw-Hill, it's going to say, no, you got it wrong, because we've got to identify this guy over here as another perfect square, or the difference of two squares. Sorry, difference of two squares. So I get what? The square root of that guy is x, and the square root of that is 4. So I get x plus 4 times x minus 4. Now, why am I not doing anything with this one? Because it's not a difference, right? Not a difference. It doesn't have a subtract sign in between the first and second terms. It's a plus sign, right? So you can't simplify this one. So it does, in other words, it doesn't factor. This one does factor. Okay. Hey, good luck with the homework on the first 7. Come back, watch video 2 to learn how to do 8 through 16. All right.